Okay, today we are still in Unit 1. We're going to work on function compositions. So this is again another concept that you have seen in Algebra 2, and this is the second time you're seeing it, but it's still difficult for a lot of students. So you might have to watch this video more than once, but just bear with me. Why is that so large? Okay. Given two functions, f and g, the composite function is denoted f composed with g. And usually when I see this, immediately I write f of g of x, okay? So let's go ahead and look at our first example. And I have a lot of this written down because I'm afraid I'm going to run out of time. When I see f composed with g of 1, we're going to write f of g of 1. Now, first, let's figure out what is g of 1. We always start on the inside. G of 1, and here's our g of x. We're substituting in 1 for x. So 4 times 1 equals 4. So there's our g of 1. Now we're going to rewrite 4 into our function here for g of 1. We're just going to substitute it in. So f of 4, because 4 is the same as g of 1, f of 4 is, well now, here's our f of x, 2x squared minus 3. We're going to have to substitute 4 in everywhere we see x. So 2 times our x, which is 4, squared, minus 3. So f of g of 1 is 29. There's your answer. So we're going to be g of f of negative 2. First we start and we substitute negative 2 into f of x. So f of negative 2 is 2 times our x is negative 2 squared minus 3. And that's 5. So we're going to substitute 5 in for f of 2. So that 5 is going to go right there. So g of 5, here we are. G of 5 is now g of x is 4 times x. So 4 times 5, and that's 20. So there's your answer, 20. And sometimes my dogs are about to get in an argument. Okay, f of negative 2. So we start on the inside. What is f of negative 2? It's 5. Now we substitute our 5 in for f of negative 2. So now we're finding f of 5, which is 2 times our new x, 5 squared minus 3, 47. So try the next couple examples. I have them done for you here, but I'd like to walk through A with you first. Look at B in just a second. You guys, out, go on, out. They're not listening to me. All right, so f of g of, now we don't have a value we're substituting in, so it's g of x. All right, so what is g of x? G of x is 2x plus 3. So I'm going to run out of room for this one. F of 2x plus 3. So now my f of x is x squared. So here's my new x. X squared plus 3x. And there's my x. Minus 1. All right, now we are going to have to FOIL this 2x plus 3. That's 2x plus 3 times 2x plus 3, right? 2x plus 3, 2x plus 3. So that's 4x squared. I should put an equal sign in front of there. 4x squared plus 12x. That's 6x plus 6x plus 9. 3 times 3. Now I have to distribute my 3. So I get, that's a 9. Okay. Plus 6x plus 9. And then there's a minus 1 at the end. So then we just combine all of our like terms and we get 4x squared, what's a squared? Plus 18x plus 17. Okay, so B, f of x. So we substitute in our f of x and we get, here's our new x squared plus 3 times our new x minus 1. Same process. Make sure you multiply all that out. So, and there we go. Now we don't have a value that we're substituting in. They're not telling us the value of x, they're just saying x. So we are done. And as well as C, g of f of x. So we're inputting in f of x into our g of x. All right, I'm going to move on. All right, so this is where it gets a little tricky. So when we're finding the domain of a composition, so any x not in the domain of g, and we're talking about f of g of x, any x not in the domain of g, we're inputting those values, has to be excluded because we can't input some number that is not a number. So, and also any x for which g of x is not in the domain of f must also be included. So I'm going to explain that in just a little bit. So let's go ahead and look at our two equations for example 3. We've got f of x and we've got g of x, and we are finding the domain for f of g of x. Hold on just a second. Out. Out. All right, so f of 4x minus 1. All right, so 4 over x minus 1 is our g of x, right? And we're going to put that into our f of x. So here is our x, and then plus 2. Okay, we got a little work to do here because we are going to have to add these two terms in our denominator. So that 2 is going to have to be, we've got to have the same denominator as x minus 1. So I'm going to multiply it by x minus 1 over x minus 1. Now I have two fractions in the denominator that I can add together because this is 2x minus 2. So still working in the denominator, I have 1 over, and then I'll keep the denominator as x minus 1. This is 4 plus 2x minus 2. So that's just 2x plus 2. That's a 1. Come on. There. 2x plus 2 over x minus 1. Now, keep, change, flip. Keep the 1, change the division to multiplication, and flip the denominator. Okay? So that is equal to x minus 1 over 2x plus 2. You might need to ask me a question about that in class. If you do, that's okay. So let's factor out. You always want to factor just in case there's something you can factor, something that you can simplify, but take a look here. Our denominator in our f of g of x, I mean, there's no way it's going to be equal to negative 1. So we've got two values here. We can't input a 1 into our g of x, that's our input. And we also can't have, in our f of g of x, we can't have our x value equal negative 1. So those are the two, anything else is going to work. So here's the second way of looking at that. Okay, you could also think about the domains. So the domain of g of x, well, x just can't be 1, right? And that was, we had already decided that. See if you look at the denominator, x can't be 1. Also, g of x, we're inputting that whole thing, we're inputting that into the x for f of x. So this value is in the denominator. Whatever that is can't be equal to negative 2. So g of x cannot be equal to negative 2. And I'll just write because 1 over negative 2 plus 2 is 1 over 0, and that's undefined. So I'm going to go ahead and set my input equal to, or not equal to, however you want to think about it, negative 2. Now, I'm going to solve this, and this is algebra. You might have a question about this, but I'm just going to go kind of quickly. X minus 1 equals 4, so that's negative 2. X plus 2 equals 4, so x is negative 1. All right, so it can't be. So we're getting the same answer here. X can't be 1, x can't be negative 1. So I'm just going to write over here in red, domain, and it doesn't say how to write the domain, so I'm just going to write it in set builder notation. F of g of x is x such that x cannot be equal to 1 and x cannot be equal to negative 1. That's it. Oh my gosh, that is a 1, people. Okay, so moving on. Using a table. So f of g of 1, think of that as f of g of 1. Okay, so we always start on the inside of the composition. What is g of 1? Well, here's my 1. When I input 1 in for x into g of x, I get 0. So I'm going to go ahead and rewrite this as f of 0. Now what's f of 0? Well, when I put in 0 into f of x, I get negative 1. So that is, let me move. Here we go. Negative 1. So number 2, f of g of negative 1. All right, well, in a different color. What happens when I substitute in or input negative 1 into g of x? So I get 0. Which we already know is negative 1. And different color. G of f of negative 1. All right, what happens when we input negative 1 into f of x? So we get negative 3. So I will substitute in negative 3 for f of negative 1. Now, negative 3, when we input that into g of x, we get 8. And the last two types of problems, and sometimes you'll get more than one answer for these problems, but if you're finding the components of a composition, so they give you the composition and then they ask you what's f of x and what's g of x and what could they be. We'll just take a look. So if this was my denominator and that was g of x that I had inputted into f of x, my g of x would be x plus 2. And then that would be my original x, the x plus 2. So f of x would be 1 over x. And similarly with b, if I had my input, my g of x, because this is f of g of x, right? If my input or my g of x was x squared minus 4, then the original function, the x squared minus 4, would replace the x. So that would be f of x equals the square root of x. And that is all, I think. Yes, peace out.